All right, Genevieve. All right, I think we'll go ahead and how about we go ahead and get ourselves started. I was looking to see if my other two partners in crime, my colleagues here, Lamont and TJ, they're not with us here. I assume Lamont will be popping on, and TJ is on vacation, enjoying some time, I believe. So we're going to move on without him. I really appreciate everybody joining us tonight and this what month we're in, this August meeting. So just got a few things here, and we'll just get right into it and do our thing. First, I just really wanted to appreciate and just call out some of our sponsors that we have here. Just so important, these meetings. There's a lot that goes on in the background making them happen, or from a speaker to the site, the location, for having a dinner, a dinner sponsor, all these things. It's important, makes it fun, and helps it go on. But there's a lot of work on the back end, so really appreciate all that and everything. But tonight, so I know that we have Adrian Welsh here from AirTech in Coast online. Adrian, I just want to give you a minute to take the floor for a moment there. Anything you'd like to share with us? Thanks for being our dinner sponsor. It couldn't be a live dinner sponsor, but he is sponsoring the raffle piece tonight. I want to just hand it over to you for a minute.
Oh, thanks. Appreciate that, Anthony. So yeah, as you know, I'm with Coast and AirTech. Coast, we're very well known for our air duct cleaning, fire damper, life safety testing as well. So a lot of these services we provide help your facilities kind of stay in compliance when it comes to indoor air quality. For example, if you guys have any projects in your hospitals that are, the existing ductwork is going to remain, you definitely want to have that cleaned before getting it balanced. You won't get a true balance if your volume dampers and on your return or exhaust side are a little dirty. So we do offer free inspections. So yeah, feel free to reach out. And yeah, we do a lot of indoor air quality services, fire life safety, firewall restoration as well on the hospital side. And our AirTech is more on the commercial side, as well as like our maritime. We do a lot of work cleaning ductwork for some ships out of Mare Island, for the Coast Guard and for the Navy. So a lot of fun stuff with both companies coming together. So we'll be one big happy family here in the near future.
Awesome. Thank you very much for sharing that with you. And again, thank you for being available for this group and always participating in all this stuff with C-Sheet. We really appreciate it.
Anytime.
Yes. Also, some of our gold sponsors here. Again, we just absolutely can't do it without our gold sponsors and silver sponsors. And I'm just kind of looking on my screen, make sure seeing who I can catch. I'm trying to get better about doing this off the top of my head now with looking here. So as I see names and stuff, I know we have Kat represented here in this meeting tonight. Prevent, I don't prevent. I was like, oh, I do have to cheat. Look at my notes. I don't see Carrie. Carrie's not on. But Facts, Forensic Analytical Consulting. We've got the team here again. Thank you so much. You guys are right here, part of everything and doing it for us. All of our sites, and I know I've been working with you guys forever and a day, so thank you so much. Gordian, Johnson Controls, and then I know we have, I don't see our representative from Phygenics. I know we had Phygenics, who was it supposed to be? Soanne from Phygenics, our silver sponsor. So did I miss any sponsors who are actually here live? Any of our gold or silver sponsors?
Yeah, Anthony, it's Gabriel Hymas, Director of FS Medical. We're a gold sponsor.
I was close. I did that. I'm getting much better here. So I'm getting much better. So thank you very much. And FS Medical, how can we forget? So thank you. Appreciate it. Just a couple other announcements before we get going here. Again, tonight you're going to hear from, we have Caltrol Inc. and Tom Walmsley, who is here speaking on Vibration Analysis 101. This was something, as you remember, going back to January, we met at UC Davis. We had an opportunity to talk about what did we want to hear this year? What presenters did we want to have come in? What were the topics? And this was one of them that came up big on our list. So here we are at this moment. So really appreciate it. Tom's going to be just has great information for us. Going to make it simple. And I know, so looking forward to this. Our next meeting, just so you know, if you don't have it on your calendars, is September 14th, 5:45 to 7:30. As of now, we are scheduled to be at Doco Kaiser downtown. And the speaker at this point is on our screen. That'll be Dave Lockhart. And speaking and about starting your RCM program, I was lucky enough to go, which is perfect time to my next announcement. I was lucky enough to hear him and a plenary panel at ASHI because I was at the 59th annual conference in Boston. It was amazing. The speakers were just, it was just top notch as it gets. I think they were almost back to full capacity, if I'm correct, from before COVID. I mean, it was a fat full room, and it was just amazing to see. The speakers were great. It gets better every year. So if you don't go, if you haven't gone, I suggest that if you're one of our affiliate members, my goodness, kick and scream to be the one to be there. You don't want to miss it. So it's well worth it. We also got to hear Dave Lockhart being announced as a participant, not a participant, candidate for upcoming ASHI president. The whole parent group, the whole ball of wax. So, man, congratulations, Dave. And I know there's been a lot of things going on LinkedIn about vote for Dave, but we need the vote for Pedro shirts. We need the vote for Dave shirts. And but with that said, I'm very serious about this. This is our opportunity to get somebody. We know Dave to be just, he's done so much for our organization and healthcare facilities. And this is a chance for him to live out his dream and for us to have a California representative, somebody who knows what we're about, how we do it on the West Coast, and just who could be an advocate for us on a grander scale. And so you got us on your side, Dave. And for everybody, this is my 2 cents pitching to you guys to make sure you vote for Dave. Get out there when that 10 comes up. And I believe it is in September, the votes?
Yeah, September 19th is when the votes open up. And I just saw an email earlier today that Ashley sent out about voting and being prepared for it. You can click on a link and it'll go to all the candidates that are running for president-elect and read a little bio. And we answer, I think, 3 or 4 questions about what we hope to do and accomplish in the role as president-elect. So read those, and yeah, definitely appreciate all the support. Anything you post, I'm not supposed to go out there and really campaign and do other things, but those that know me are free to support and put things out there. So I've already had some amazing connections and shout outs and other things, and I greatly appreciate it. But yeah, as we get closer to September, we want to make sure people know that I'm running and out there. So appreciate all the support, and really would love to fulfill this dream and get into that role and help represent California, CSHI, Region 9, and ASHI as we go forward. So very excited about this opportunity. So thanks for that, Anthony.
There it is. My goodness, everybody go fill those ballot boxes. No hanging chads. Let's do it right here. But make sure you get your vote in. If you know somebody across another state, reach out to them so we can get more votes, the better. Couple other things here. The seminars are coming up. Northern California, and if you're into that type of thing, Southern California. Hey, so we have our Northern California. I'll start with that, October 20th. If you don't have the date pinned already, it's going to be in Fairfield, California at the Marriott Hotel. A full day of just great presentation again. It's just really depth quality presenters and top-notch information. So make sure you get there. Registration is open at this time, so definitely jump in. And if you're going to be, you're like, I'm not in town, I'm going with my spouse down to Southern California on our anniversary or something. Well, you're in luck. There's one in September 15th in Long Beach. And you can tell your spouse, say, hey, hold off on this thing. I got a presentation to go to, and go to the seminar down there. So both are open. It's called Leading the Future. That's the title for this time. So I hope to see you there. I'll be there and whatnot. Finally, last couple of things. The MEC study session is, we do have a study session this Friday. It's on power plant and boiler. You can't register for the study session on the CSHI website. But the actual MEC test is coming up, and I know Beth is on here. Hopefully she's listening to me here, and I say the date right. I believe she said it was MEC exam is on September 15th.
There's one at the Southern California seminar on September 15th, and then there'll be another at the Northern California seminar on October 20th.
There
The
you
important
go.
thing to remember is that you have to register for the one at the Southern California seminar by tomorrow,
Hmm.
close of business tomorrow. And you have to register for the one at the Northern California seminar by September 15th.
More reason to go to the October one, gives you a little bit more time to study, a little bit more time to register. So register now, but gives you that little extra study time up here in October. So there you go. Let's see here. The annual institute. I don't know how many of you were with us in Tahoe. That was awesome, except going up the side of that mountain in that little cart. That was awful. But once you got up there, it was really good. For those of you who were there, you know what I'm talking about.
That was the best part, Anthony. Come on.
Brutal.
It was certainly better than staying in the dark the first night.
It was certainly better than staying.
It was a great ride.
Well, if you were there and you thought, my goodness, I could plan a better institute than this. There's all these things I can figure out that we didn't do here. Well, this is your chance. I'll be leading up the planning for the 2023 institute, and I am reaching out to you to be on the planning committee for that. If you'd like to, send me an email, shoot me a message and say, hey, Anthony, I'd like to be part of it. Lots of work, many hands makes light work. And that's what we're looking here. A lot of good thoughts and ideas. So definitely reach out. Love to have you there. And my final one here is expect an announcement here very soon for the chapter holiday party. We got something up our sleeve this time. We totally do. We got something up our sleeve. And we got it. We're like, it was great last year coming back for the first time. It was the beginning of COVID, but we got a little bit something up our sleeve. We're like, oh yeah, we're going to pull this off. So there'll be an announcement here really soon. We're working something out between TJ, myself, and Lamont. So anyways, thank you for just bearing with me through those announcements and information there. Anything else you need, the cc.org website's there. You got the executive, the state executives here to serve you. Thank you. For those of you, is there anybody else new for the very first time coming to one of our meetings here?
I am new. This is my first meeting. This is Joyce Fuss with Lionakis in Sacramento.
Nice, Joyce. What brings you here? How'd you run into us? What brought you here tonight?
This meeting was recommended to me by Matt Melcher, who is my boss, and I don't see him on here, but he was tentatively going to join as well. So interested in what's going on. I'm a structural engineer.
Some extra game points there for you. Thank you very much for joining us, and hopefully you find this to be just beneficial for your day-to-day work and everything, and help you grow a little bit. So thank you, appreciate it.
Thank you.
If we were live, I'd pin you, get a little pledge pin thing there for you, but we're not live, and so next time I see you. All right. All right. Well, with that said, I think we're going to get over to the main event. The whole reason you're here is not to hear me. You get to make sure I have my notes here.
So Anthony, if you don't mind, I'd like to introduce Tom, and
Please do.
because actually I have to kind of apologize to the group, but unfortunately COVID is still hanging around a little bit. We were supposed to be live at my facility in Roseville, and I was really looking forward to hosting it because we were actually going to not only do this presentation, but kind of go see some live application of it, because we've been working with Caltrol and Tom Walmsley for a very, very long time. Unfortunately, over COVID and some other changes, we haven't been as engaged as we need to be, but I'm working on getting that mojo and momentum back up, because I actually started with Caltrol before they were Caltrol. Boy, now his name just slipped me, but a gentleman who kind of went out on his own, started Vibration, worked for a motor company, and was taking care of our facility for many times. And then he kind of emerged with Caltrol, and been using them to really, really understand what's going on in our facility. One of my first big wins when I first was working on getting that program in is we had a cooling tower, one of our gearboxes, and this was right before the hot season. So in spring, we did a vibration on there and found out that we had a bearing getting ready to go on there. And I would have been SOL in the heat of summer when that would have grenaded on me. But using vibration analysis helped us to pinpoint and see what was going on. And as you'll hear next month, if we do get live at DOCO, talking about an RCM process of understanding your risks, understanding the failure modes of your systems and your equipment, and what best tasks to apply to your different systems, and understand where your failures or risks may be. Vibration analysis, ultrasound, oil analysis, a lot of things play right into that condition-based monitoring. So understanding vibration and our rotating equipment and or other things that we can apply to are very critical. So Tom has been definitely an ambassador and a key partner for us. And I really think everybody's going to get a great deal out of this vibration analysis 101. And so Tom, I'll let you kick it off.
Okay, let me, good evening, everyone. Let me share my screen here with you. Let's see.
Shannon Harwell. There it goes. It just came to me. My brain was frozen while I was talking, but Shannon was the gentleman that used to work with Tom.
Yes, and he still is. And I'll apologize in advance. Shannon and some of my other colleagues usually do these. I don't do these too often. I'm the service manager and run all the guys. So I apologize if I stutter and stammer along the way, but I'll do the best I can here. Everybody see my screen okay?
We can.
Okay. Yeah, well, Dave just introduced me. I am the service manager for Caltrol. Been with Caltrol / Redline for the last 17 years. Prior to that, I was in the electric motor repair industry and ran motor shops for a long time, 35 years. So I'll just give you a little background on Caltrol. Caltrol is an Emerson Impact partner. Many of you probably deal with us already, where we do everything that's process management, reliability, vibration analysis. Those tools, whatnot, are just a small part of the company, but we go to market for Emerson through all the different impact partners around the country, as you see in that map right there. Along with the predictive maintenance programs that we run, which this is based on, we also, being an Emerson Impact partner, also sell the analyzers. We mentor for facilities that want to do this on site themselves. We sell online devices, wireless devices, which you'll find that we have installed on a lot of the OR air handlers at hospitals, where they want continuously monitoring those all the time, instead of just whenever we come out to do a route collection. We do consulting. We'll do your whole CMMS program for you, and a lot of other types of services around reliability. Why use predictive technologies? I like to use this one because it's we like to show that basically when using predictive technologies, we like to use this curve here where you'll see, we identify, problems very, very early in the stage of this curve. And as they advance, we watch the progress of them and escalate the priorities on them. And you show the early the stages where you don't really see anything visible or hear anything, and then it gets to the point where if nothing's done, you get audible noises, and it gets hot. And then next thing you know, you have a failure like this on this turbine. So we like to associate predictive technology kind of like machine doctors. Basically, we use vibration as the heartbeat, the pulse of the machinery. Oil technologies, consider that with the blood. Thermography, taking the temperature, doing motor current analysis, the brain waves, and we also do sound analysis as well, and kind of gives you a simulation of the same thing that doctors do to patients. Let me move this here. Failure mode effects and analysis. Dave was just talking about that, and these are some of the what reliability centered maintenance used as a strategy to find out what technologies to use and why use them based on the types of failures that you would be having. So I could use this one as for a typical pump. You'll see all the different types of failures that happen, and these are in the order of what can be used in, and the types of failures that happen for the most part in the order that they happen. We find that 80% of failures in the pumps are happening either from a bearing fault, lack of lubrication, imbalance, or mechanical looseness. Those are the top candidates, and vibration analysis targets that. And we'll talk about peak view. That's a bearing technology, and we'll talk about that a little bit later here in the PowerPoint. Vibration analysis. So of all the technologies that we deploy for predictive technologies, vibration analysis is probably the #1 tool and that we use for rotating machinery. And these are just some of the defects and types of failures that you can find using vibration analysis. Basically, we come out, we collect data with an analyzer. The data gets downloaded to a software back at the office where the technician will look at the data and analyze it and then create a report from that. Now, while he is on site, if there's anything that we see, he will get alerts on the analyzer itself if there's something major that needs to be told to the customer right away while we're still on site. But for the most part, we collect the data. The 2140 collects the data so fast now that the older analyzers used to pop up on the screen. You could see you see the spectrums displayed for a second before it would actually move on to the next point. But the technology has gotten so advanced now that it collects the data so fast that you'll get a high alert alarm, but the view of the spectrum flashes by really fast. So most of the analysis is done back at the office after the data has been downloaded. Some more faults that are all identified by using vibration analysis. So vibration. So vibration signature, it contains so much valuable information that we're seeing. Through the motion of the asset that we're monitoring, we can see low frequency events that are usually imbalanced, those types of things, misalignments, and then where there's also, we're measuring the bearings through vibration, which don't necessarily create a vibration that anyone would recognize from human touch or even sound or anything, because we catch these things in the very, very early stages of bearing failures. And the technology is so intricate that we can see faults on bearings, specs on a bearing way early in the very early stages. So There's a bunch of different levels of things that we're looking at when we are using vibration analysis. This is a typical motor train, basically a motor, a gearbox, and to a pump. And it just shows the different points where we'll collect data on these units and the types of areas that you'll see the different types of problems in from those points. The positioning on how we collect data on these assets. This is a typical fan unit, which just shows if any of you are using vibration analysis or getting reports, you'll become familiar with some of the technology and the acronyms that we use for the different fan positioning points that we collect the data on. We take readings at basically when we come out and we're collecting data on any rotating asset, we collect a set of readings at each of the bearings because that's where that's where the information is transmitted best through, because you have the casing and a rolling element bearing that will that is close within vicinity of that versus, there's no airspace or anything. So that's where you always get your best readings. We take them in 3 directions: horizontal, vertically, and axial at each bearing point. We used to do this back in the day where we would have a single channel accelerometer where you had to move to each of those positions on that one bearing. But now we have what's called a triaxial accelerometer. So you put that in the horizontal position and it'll collect. It collects a different spectrum for each direction, but it does it without having to move the accelerometer to those different positions. Plus it takes a 4th one, which is called peak view, which again, I'll get to here a little bit further in the demonstration. More measurement point locations. Again, as I was referencing here, this is a horizontal point where we would get the horizontal point on that fan bearing, but we don't have to move up to the vertical or to the axial anymore because we can get them all just from this one position here. These are the different types of sensors that we use for gathering the vibration data. Velocity sensors are pretty much obsolete. You don't find those anymore because the standard accelerometer covers all the low frequency range, high frequency range, bearing defect faults. Pretty much they're advanced so much that velocity sensors have become obsolete because they will not get high frequency ranges. They do have their place in the industry, but I can't remember the last time I've seen one. So pretty much everything is measured with accelerometers, and that would be through a contact through a ball bearing, because we're picking up waves through the contact of that bearing. Now you also have the other type of probe that is used is called a displacement probe. And it's an eddy current sensor or mostly they're the eddy current sensors, and what they're used on sleeve bearings because as you know, on a sleeve bearing, your shaft is running on a film of oil, so there's really no contact. Where the accelerometer will miss things on a sleeve bearing because it needs to transfer through that ball bearing to pick up that information, a displacement probe actually goes down into the oil bath, and it's measuring the movement of the shaft. So that's what is used on, you'll find that mainly on turbine generators, not too much. Some chillers have some sleeve bearings, but there's not too many assets in the hospital industry that have sleeve bearings. Maybe some old fans, but I think those are pretty much obsolete now too. And this is a different type of mounting that we use in the magnetics that we use on the accelerometer. We use a flat magnet or a rail magnet to get onto the curvature of a motor or a bearing or whatnot. These seem to work the best. A lot of cases where you'll have air handlers where we can't, basically, I'll show you in another video here, but the accelerometer is attached to the analyzer the technician walks around with, and he uses a magnet on the end of the accelerometer and just moves from one point to another on a machine. But on air handlers where we can't access, or cooling towers where we can't safely access the fan bearings or the motor bearings, we'll permanently mount accelerometers, low-cost accelerometers, right onto the bearings, and then we run them out to a junction box where we can collect safely on the outside. This is usually one of the one of the detouring costs of getting a program started, because unfortunately there are a lot of air handlers where they're not accessible, and there's a bit of a cost up front to outfit those air handlers so we can collect the data on them. But once they're installed, they're generic. They're 100 millivolt per G. It's a very common accelerometer in the industry. They're used, and they run out to a BNC connection, and they'll run with any type of any other manufacturer's analyzers. So they're not tailored to one type of analyzer manufacturer. And they're on there. Once they're on there for the life of the machine. You just take them off when you change bearings and whatnot, and retap them and put them back on. These are some of the terminology that we use in the industry. Amplitude is the amount of movement that the asset is moving at. We measure these in 3 different types of measurements. Displacement was usually used to measure slower moving equipment. It's also a measurement we use when we're balancing a fan. Velocity is your overall measurement that is used mostly, and an acceleration is for looking at bearings up in the very high frequency range, since that's where they'll show up. Frequency is the time. So we take amplitude versus time that we're looking at RPMs. We measure everything in CPMs, which is relative to RPM. It's cycles per minute. So basically it reads at the same as the RPM. If any of you are familiar with vibration analysis, you'll also, a lot of technicians use Hertz. It's a lower number. It's basically the CPM divided by 60, and that's how you come up with Hertz if you're using that terminology. And then orders is the number of the revolutions or orders of how fast the unit is running at. So one order would be at speed. 2 orders would be at 2 times of the speed of the fan, or whatever the machine is that you're testing. Phase analysis is also, we look at phase is we're measuring two planes here, but we're getting a phase angle off of those, and that helps us determine, every piece of equipment when it's moving moves at a certain phase angle. When we're balancing, we're looking for, we use those phase angles to determine where to put weights on. In a bearing, a lot of times, if something is, we're determining the imbalance, and if it's in phase, that means we would affect both ends of this fan wheel in the same angle. Sometimes they're out of phase with each other. So if you put your accelerometer in on both the same angles, you may get 180 shift out of that, which is, it's called it's uncoupled balance on it. These are some of the plots that the technician looks at when he's back in the office. This is what it looks. These are what some of the different types of units that we're measuring in, and this is what he's looking at when he's doing his analysis. Trend plot. Everybody understands a trend plot. If you have something that's going, you have a fault limit here. These are all the different the times that data was collected on them. These could be monthly, they could be quarterly, they could be weekly dates. But as you can see, the amplitude is increasing. We use trend history as probably our most valuable tool in doing predictive maintenance. Waveform, this is the raw data that everything else is derived from. This is the the actual vibration, the amplitude versus time waveform. So if you took this waveform and you stood it at and you turned it 90 degrees, this is basically what you're looking at when you look at a spectrum, which is the down here. And this is the amount of amplitude that it's shaking at, or whatever is happening with it, depending on what frequency this amplitude is at, and then this is time and CPM here. I'll go back to the bearings and when I was talking about what types of probes and proximity and accelerometers we use. That's what I was just talking about: sleeve bearings and rolling element bearings. So each one of these components within a bearing has a certain frequency that we can pick out of our spectral data, and anything that happens with the bearing, happens at it has its own frequency. We can enter these into a library if we know what the bearing number is, and it will actually we can program those fault frequencies into our software. And then this is a sleeve bearing, which I was explaining. It's just a shaft that runs in the sleeve and runs on a film of oil. Well, I just covered that already. This is where we had where eddy current probes measure the movement of the shaft, because there is no contact with this shaft in a sleeve bearing. That's where an anti-friction bearing, there's contact being made all the time. That's where an accelerometer is used. Orbits, that's one of the things that we measure on a sleeve bearing. We watch the dimension of how this is moving within the bearing, and we can measure that orbit, and if we can tell if it's starting to get too much clearance in there and the bearing is starting to wear. So we like to use the analogy of your car, basically. Every day, what we're doing when we're collecting data is we're gathering data, and we're looking at all these different frequencies and trending them to see if the data is trendable over time. And when we see a change in that data is part of our analysis. It's kind of like when you're you're driving your car every day. You create a baseline. So we come out, we do we take our first route, we get a baseline on the data, on the asset, and we have a baseline data to compare everything else to moving forward with our next rounds of data collections on those. So, and we have something to compare it with. It's the same thing like you do on your car, when you listen for different sounds when you're driving your car, and as different sounds change, the same thing is happening when we see a change in vibration data. For example, like your tires, your belts, you hear those different whines and rumbles. So frequency bands. So when we're measuring, this is a typical spectrum. What I was talking about is where we see, we'll set up bands with every set of data that we collect. And again, you may be using some things, or some vibration pens out there where you're getting a number, basically, that you can trend, and it has value too. But it takes a number. It takes all these frequencies that we're seeing within a spectrum. Each one of these frequencies represents something on the machine. When you're just using an overall pen or something, you use vibration, what that's doing is it's taking this number, this amplitude number here, it's taking all of these frequencies, combining them together and giving you an overall number. Now we use that overall number too, because that's part of our trend for for seeing a change when that overall goes up, because that trend's steady as well too. But when we use an FFT analyzer, we break it down into different bands. So we have probably 10 different bands of vibration data, and within those bands, there each thing that happens on there, it represents a different a fault in the asset. It's part of our analysis. Again, here's a typical a spectrum, an imbalance issue. And just showing all the different frequencies with the different bands of where things go on with it. Again, here's more talking about the bands, the different bands that we see, where things happen in the spectrum. Gears and bearings will show up very high in the spectrum. These types of things you won't even see in an overall spectrum. Another trend plot. Here's an example of this is a trend plot where the low frequency amplitude is trending steady. So if you just had something that was monitoring, even if you had a device that didn't have peak view or was monitoring the bearings on a separate band, the overall amplitude never increases much, but the bearing frequency and the faults going on that is increasing into alarm. But these levels are so low, it doesn't affect the overall, and you'll never see it unless you're doing in-depth analysis. Here's another example of an alarm limit where there's the alarm limit set here at 0.1 inches per second, which is pretty low. But you do have a lot of events going on with bearing frequencies down here in the higher frequency that are not affecting that number. here's one where there's still more going in. The rotational frequency of the amplitude is reaching an alarm level here, but it's low still. But that's all you're going to see in an overall alarm level, but you won't see anything that's going on with the bearings. Which is I was explaining, these are so low, they have value to us as we're looking at bearing fault frequencies in there, but they're not affecting the overall number because the amplitude's not high enough. Now they will, when they get to the point of failure, they will create enough amplitude that they'll trigger this alarm. Again, here's some more machine defects that are detected with vibration. So here's a typical imbalance. Basically, it happens at 1 times rotational speed. So as I said, RPM or CPM, this will be at the actual rotation of the fan. Basically, when you're seeing a high amplitude, there's a heavy spot on the fan wheel itself that's rotating around, and we're catching that, which is creating the movement in the unit. And this is what a waveform will look like with imbalance. It's sinusoidal, very sinusoidal, and with this measurement of from the peak to peak is how we measure the amplitude. Is how the analyzer measures the amplitude of how far out of balance that unit is. Without getting too far in the weeds here, I mean, this is some of how in our determining of an imbalance, because things that happen at 1 times rotation aren't necessarily always in balance. Other things are going to happen too that cause the 1 times rotational frequency to go up. But typically, if it is a balance problem, we'll see the highest amplitudes in the horizontal directions. Vertical will be fairly high, and axial will usually be pretty low. And that's because in the vertical position, you have the hold down of the structure that's holding it down, and you have the most movement in the horizontal direction. Two times running speed will usually represent misalignment. Looseness. It's a bearing fault. So amplitudes like or high amplitudes from misalignment, imbalance, those types of faults, low frequency events, your machines will run, they may shake more than the other one next to it, but typically they don't, unless they're really bad. They'll they'll start breaking things with the structural bolts and cracks in frames and stuff like that. But if they're they're not running at a really high amplitude, those machines will usually run, if they have a little bit of those issues in them, for years without ever really giving any problems. The problems that we see that create and manifest themselves into catastrophic failures for the most part are bearing faults and looseness, which these happen at very low amplitudes. So you don't even feel them or recognize them through human touch and sounds and everything until they become bad. Mechanical looseness is, for an example, is we'll see this. You see the amplitudes are very low, but we'll see multiple harmonics of the running speed in the spectrum, and that combined with other tools that we use will determine that looseness. This is indicative of, like, you have a bearing that's in a housing on a pump or motor or fan or whatever that's spinning and it's getting worn in there, or it's worn on the shaft and you start spinning in the shaft. I'm sure you've all seen those failures before. Very hard to detect because they don't create a lot of movement. Again, what I was explaining here is the on a bearing fault, on a bearing, on a ball bearing, each one of these components of that bearing, the outer race, the inner race, the balls, and the cage, all have a frequency, and they all can be detected through vibration analysis. As you see here, this is a peak view spectrum, which I'll get into. They're all represented, and we can pick those out. Peak view is also used for gears. If you have a cracked tooth, we can see that with side bands of rotation. This is the rotation of the gear itself with harmonics. Now we'll get into peak view. So every manufacturer, you'll see bearing faults in standard data, which most analyzers are collecting standard data, and it happens way high up in the acceleration spectrum, and you usually don't see anything until they've gotten to the point where they're about to create a catastrophic failure. But Emerson has developed a technology called Peak View, which filters out all the low frequency amplitudes and it only looking at metal to metal impacting. And basically what I just said all right there. Here's a waveform of what we'll see when there's impacting going on from a bearing fault and the spikes that are going on, it's per revolution of those balls and that. And then this is what the waveform looked like after the bearing was replaced. Again, I don't know if you guys can see well, but for these little spalls on the balls, we can pick those out. This is a progressive stage here. These are making noise at this point, but when there's just a little speck on there, Peak View will pick that out. Again, here's a spectrum of a bearing fault, and this bearing is programmed into the software, so we can actually see that it's the ball pass outer frequency or the outer race of the frequency of that bearing that's showing up here with harmonics, and you see all the impacting going on in the waveform. And anything that we low frequency, like all the imbalance and all that stuff, is all down here. It's all filtered out. You don't see it at all. And that's about it. Open for questions.
Hey, Tom, this is Mike Messer, Chief Engineer, Vacaville Kaiser. I had a question about your guys' band balancing. Are you guys able to, how do you guys do that? Are you able to get your analysis from the fan without being in it while it's running?
Absolutely. So this is the one thing of the job that we do. Most people think that, well, you don't want things running when you're working. Well, we're the opposite. We need things running for us to be able to test anything. But yes, no, the answer to your question is, if we come out and a customer suspect of imbalance, we come out, we collect data on the asset before it's shut down, and we can do pretty much anything we need to do, as long as we have access to the bearings, to the fan bearings, as long as they're accessible, and the motor bearings, because we'll do a combination. Sometimes it's, a shiv or a motor can be causing the problem, the imbalance in the fan. Well, where everything's shaking, you may think that it's the fan that's out of balance, but it's actually something else that's causing it, which is a good percentage of the time it is something else that's causing the vibration. But to answer your question, yes, we come out and analyze all of that without shutting the unit down. Now, like I said, if it's in a housing in an enclosure where the bearings are inside and you have to go in through a door to get into it, we'll need to shut it down long enough to run accelerometers in there. We'll run them back out the door and start the fan back up. And even if we have to balance the fan, the time that the fan is down is very limited. We run it just to put a trial weight on it, then maybe the final correction rates, but it's never down for more than a couple minutes at a time.
So you can add weights or pinpoint where the weights need to go without somebody being inside the unit.
Well, we have to, yes. If we have to go in and set up our equipment inside, and then we come back outside to do it afterwards. But yeah.
Okay, yeah, that's great. That's good to know.
Oh yeah, it's just like a car getting your tire balanced. As long as we have access to the fan bearings and we have access to the fan wheel, which normally you do, we can balance the fans in place. And it's in the industry with electric motors and whatnot, they hold a tighter tolerance from imbalance from the factories, but fans are I don't know why, but they haven't been held to real tight tolerance, and they are out of balance quite often.
Yeah, I think I have a few I need checked.
More than happy to.
Yeah, thanks for that. I appreciate it.
Hey, Tom, this is Dave Lockhart. Wonder if you could talk a little bit about frequency of pulling samples, and or if you have some guideline for what assets are better to be monitoring and not really worth monitoring, because there is a cost to all this stuff. So
absolutely,
maybe a little guidance on that.
Anything that's running 24/7 has no redundancy and is going to be extremely impactful if it fails. You want to monitor, if you're going to monitor it through a PDM program, through a route-based program, you really should be doing those monthly. Most hospitals that we do on a quarterly basis, and we've found that that seems to be fine, even if the units are running 24/7. We do have continuous devices, and they're getting very, very reasonable in cost. And the future of the industry, which I'm seeing already, is, and you guys have probably been approached by, there's tons of companies out there that are just startup companies that haven't even been in the industry for very long, that are manufacturing these cheap devices that are wireless devices that you can put on your asset. We sell them too. Emerson ones are a little more sophisticated and expensive, so we don't compete as well with some of the cheap ones. But the things that we get out of our devices are much more sophisticated than some of these others. But that is where the business is going. Sorry to get off track here, Dave. I'll get back to the frequency, but it is where vibration analysis is going. That's how far it's advanced. Is that the days of route collectors coming out to do it are going to be gone, and there's going to be these devices, and we're doing this now, where we can sit in our office and key right into these devices, which are monitoring continuously. So when we come out and take a data collection, we come out, we're getting however that unit happens to be running at the time that we collect the data on it. And we go back and then if we don't come back out for another 3 months, we don't know what, that's all the data that we have. With these devices now that are being, they're continuously monitoring, they're always getting data off of them. And they set up alarm thresholds. So they set up alarm, they send alarms to your DCS system to let you know something's going on. And then, we'll get the call. There's someone, now they still have to be, someone has to analyze that data. But even that is progressing to the point where the machineries themselves will be analyzing the data. There's just a lot of information that has to be put in for it to be able to do that. But that is the future. Getting back to the frequency from a route-based collection, anything that's, what you maybe don't have in the program is if it's, where you have multiple redundancy to the machine. Is it expensive to replace if it does fail? Those are the determining factors to not have something in a program. But to monitor, to run a PDM program, it's relatively cheap. Anything where you have redundancy and they rotate back and forth, a quarterly vibration program on those assets is fine, because we have to, half the time, have to have an operator start up the lagging equipment that's not online. If you have a good rotation program, a lot of customers use our reports for their rotation, to use as a time to use for the rotation of their equipment. So we send them a report and they see that, the secondary water pump wasn't running. Well, okay, let's have that one running. And now the other one's down the next time that we come out. So you're continuously getting data on all assets. And then like in the hospital industry, I think quarterly is pretty much is a good frequency for all of your equipment. Again, OR fans, maybe a little bit sooner, but we have a lot of continuous monitoring on those devices. So they're always being monitored.
Tom, this is John Martinelli. One of your early slides showed that arc where you get an early stage 1 failure and then stage 2, and then it goes on to become a catastrophic failure.
Yeah.
Is that a fairly standard curve, or have you ever experienced certain types of equipment that may go from an early stage failure to a rapidly catastrophic failure?
You do. So when I was talking about looseness, we put a high priority when we see a looseness problem, just because of that. The bearing's already spinning, or the shaft spinning inside of the bearing, so it's wearing down the shaft. What happens when you have that is the bearing stops turning and the shaft is just moving inside of the bearing instead. And eventually that shaft will wear down. And then if it's on a motor, the rotor is going to run into the stator and it's going to fail. And for the most part, most motors you guys have, the smaller stuff like that, are throwaways anyways. But you just try to avoid catastrophic failures. Bearing faults, while we detect them so early, sometimes that's a curse, even because of peak view, because we'll open a problem on them from peak view, and there is a fault there. But sometimes a bearing will run for years with a bearing fault. Other times we can you detect a bearing fault, and a week later it craters. It's hard to detect, but for the most part, we see a good trend of progression, and we change our priorities for the problem. When we open a problem in the early stages on a bearing fault, in the report that we send to you. It'll just be under a trend status, let you know we've identified this, we're trending it. You know, we come out next time. If it escalates and gets a little worse, then we'll upgrade the problem to, okay, now go, maybe consider changing the bearings out at your next shutdown, or and so on and so on. And then, you know, anything that's really bad will have an immediate attention priority on it. But I mean, yeah, I mean, there's still science involved in it. You know, it's not 100% you can predict the day anything is going to fail, but identifying them, knowing that it's there is worth so much. It has so much value in it.
Hey, Tom, this is Dave again. One of the other slides that I think is pretty powerful that you didn't get in a lot of detail, but how many different things. I mean, we think of vibration analysis just on the rotating equipment, but how many other faults? You talk about looseness, bad footing, the alignment. You know, I think there's probably 40 different things on that slide that you guys are able to pick up and to do vibration analysis early on as a spec for installation or new equipment coming in that can really help you understand, hey, this thing wasn't built correctly, wasn't bolted in, wasn't installed well, that there's, you know, just so many things that can go wrong that you can't pick up. So it's not just that bearing and there you go. That's the slide right there. I mean, broken rotor bars, crooked cock bearings, soft foot. I mean, there's just so many different things that you can detect early that may not just be the bearing, but maybe other things with installation or going on with a piece of equipment. So it is very impressive what, and again, you hit on it very well. The signs and the stuff you guys were able to pick up from vibration is pretty impressive. Yeah, and again, you know, when we open a problem on something, there is a, you know, it's never necessarily one specific thing that we'll recommend that you look at, because the signatures are identifying, it could be a couple of different, because there's so many faults that are identified, it could be a couple different things that are going on with it. So we'll usually give you a recommendation to check a few different things.
Excellent. Got one more question about your monitoring. Does that live on the facility's network, or how does that work?
It can.
But does it have to? Because when you get IT involved with that kind of stuff, it seems to be the biggest hurdle to get through.
Are you talking about continuous monitoring devices?
Yeah, for like OR fan.
Yeah, well, you want those. The software does have to reside, but nobody has to necessarily look at it, but we would wire it in so that it would give you alarms to your DCS system, which is what you want. Yeah, we set all the alarms and the thresholds up on those machines. We collect the data on them manually with the analyzer, so we know how to set a baseline on them, and then we'll set limits on there so that they're running. Basically, you get a green, yellow, red light on your DCS system, and
okay, so you're tying it.
If something goes into alarm, then you can contact us, and we can, if we have access to it, to the data, we can analyze it from that point, or come in and look at it, or whatnot.
Okay, so you're connecting to the BMS, not necessarily needing a network connection.
There still has to be a network connection to do it. Yeah, we don't, Emerson, with our devices anyways, we don't go anything over Wi-Fi. It's all secure. So there's the devices feed a gateway that feeds a secure software that would be hosted at your facility, but we can remote into that software, but it's not done over Wi-Fi.
All right, thank you.
Right. Wow. Well, can we give, I'd love to give Tom a hand. Thank you very much for the presentation, and thank you. Really appreciate it. Got one.
No problem.
Once we get
Anytime.
the hands up there they go.
Yeah, if
Thank you
anybody's
very much.
interested in, you know, like I said, aside from PDM programs, the devices, you know, if you have any critical assets that you're really concerned about and that you want to, you know, that you want to consider monitoring, whether it be online continuously or through a program, we can certainly help you with that. You know, one other thing I didn't touch about, we talk about vibration analysis, but we also do thermography scans, which you guys probably do. You guys probably use, most of you probably use somebody that for that, where we come in, we'll check all the MCCs and all your disconnects and all your distribution centers for looking for hot spots and stuff like that. I'm sure you're all familiar with that. But yeah, no, aside from, you know, the programs that we run, we do, the only corrective services that we do is we do dynamic balancing on-site balancing, and laser alignments for, you know, pumps and whatnot of direct couple units. Those are the only two corrective services that we do outside of these PDM programs.
Tom, can you put a good contact for you for yourself in the chat for anybody who would like to pick that up here in the on the meeting? Sure. Appreciate it very much. Again, thank you very much. Really appreciate the information, and I'm sure you'll be hearing, we'll be reaching out to you, and we'll love to have you back again in the future and get a little bit more in depth on this. Just very great job. Thank you so much.
You bet. Thank you, everyone.
All right. For everybody who's with us, hopefully everybody's still here with us. We're going to do a quick raffle and we will make our way out of here. That was very good. Hopefully you enjoyed that. Just to wrap up here, we're going to do, again, raffle for our, this one here is for our facility members. And I'm going to share a screen here. It's coming here. And let me get on the right. Something like that. Go with that. Here it comes. All right, so tonight again, since we didn't have a live dinner again, really want to thank Adrian and Coast AirTech for taking care of a really awesome raffle e-gift card for our raffle winner here tonight for one of our facility members. Must be present to win. If you are not, we will respin that thing for our facility members tonight. So let's see who's gonna be the big winner here. All right, here it goes. All right, got everybody loaded. Must be all the facility members must be present to win. This is very dramatic, huh? This is just great.
It's actually really awesome.
Yeah, it's pretty impressive.
Oh,
Where is it gonna stop? Oh my.
Lamont is, hey, we gotta make sure it's still kind of moving there. You know, there's no tricky stuff. There it is, Lamont Green. All right.
Respin.
That's you. You got it. All right. We're going to stop that on there. You know, I'm going to make the announcement too. For those of you who don't know, I really, the Kaiser representation here is pretty awesome. It got one deeper with our winner here tonight with Lamont Green is now over at Kaiser Sacramento. He's our vice president here for the Northeastern chapter. So it's been great to have him along for the this ride here, and now participating on the other team, Kaiser. So
yeah, it's a beautiful thing, and I'm very glad to have landed there. Great group of people, and the person I report to is pretty amazing. So, and I'm saying that he's not on at the meeting, so it's a very true statement.
I was just saying, did Ken pay you for that one or what?
$20. $20, yep.
All right. Well, everybody, It's been really good. Again, our next meeting is, I'm just making sure it's next month on the 14th. 5:45, we'll start meeting up. Doko Kaiser, we're working on that. We'll work more with Lamont and Kevin and make sure we're all good to go there. But plan to meet downtown live. Great little site, and be Dave Larkhart speaking on RCM. So come prepare with a big fat notepad and lots of good notes to be taken.
So Anthony, you said the first time you said September 20th. Now it's the 14th.
No, the 14th.
14th. Okay. And then the
Southern.
Southern California is on the 15th, right?
Oh, I'm sorry. So the seminar is the 20th, October 20th.
Oh, okay. Okay.
Yes, Northern California seminar is the October 20th. The Southern California seminar is September 15th.
Okay.
Our next Northeastern chapter meeting is on the 14th.
Okay. Okay. All right.
There we go.
Hey, Anthony, this is Steve. Are we still doing the River Cats thing?
Not at this point. That we just got priced out. We got, I mean, exponentially priced out.
Oh, okay.
Yeah, not even unless somebody's really hit that $750 million lotto and wanted to put up a little dough for us here. We're priced out. So we're planning other great things, and the holiday party is going to be off the chains. It's going to be unbelievable. I don't even say that off the chains. I just said that. And that's what it's going to
Dating
be.
yourself.
So correct. Yeah. No. Unfortunately, we had that one on the docket, and we had to take it off.
Okay, thanks.
All right. Any other questions or thoughts from anybody else? Thank you so much, everybody. Really appreciate the support. All of our affiliate members, we cannot do this without you. Just for all of you, whether a gold sponsor, silver sponsor, or you just here because you're just sponsoring this chapter because you love it. Thank you so much. Really appreciate it.
Thanks, Anthony.
Thanks, John. Bye-bye.
Thanks, Tom.
Good job.
Thanks, Adrian.
Thanks, guys. Thanks, everyone.
Have a good evening, guys. Everyone. Not guys, everyone.
Bye.